Okay, I guess as people are starting to join in, we can get started first. All of the things that we presented on the webinar will be sent out to you as a video in the end. So don't worry if you miss any parts. So let's get started. So today we're very pleased to have our webinar, which was new in Milvus 3.0. So we just released Milvus 3.0, and we'd really like to help you walk through what is new about it and with our two main maintainers of Milvus. So let's get started. Let me introduce the panelists today first. So please join me and welcome John, who is the head of developer relations and solutions at Zilliz, and Lee, who is
Hey,
the director of engineering here at Zilliz. Do you guys want to introduce yourself a bit?
of course. Hey, my name is Jiang. I'm running the developer relations as it is, and I'm very excited to invite Li, who is our director of engineering, to give an introduction on 3.0. Li, would you like to say a few words before we get started?
Yeah. So, hi everyone. My name is Lee. So, now is in charge of the development of a vector database, inside Zilliz and Milvus, Zilliz Cloud, everything. And so glad to get a chance to here to share about our latest work, Milvus 3.0 to everyone. Yeah, hope you will like it.
Awesome. Thanks, Lee. Yeah, so before we get started, I would like to give you a quick background on Milvus and Zilliz. So Milvus is an open source vector database built for performance and scalability. So it has been we are very honored to receive over 44,000 stars on GitHub, and it has over 100 million active instances downloaded. Um, Zilliz is the company behind Milvus. So we are also very honored. Can we move to the next slide, please? Um, we're also very honored to be named as the leader in vector database space by Forrester Wave. Um, so today our focus is Milvus, the open source version, and this cloud is the fully managed vector database class vector lakebase service. You will hear about the difference of these two things in today's sharing, and Lee will give a more deep dive into what's the difference between those two solutions and what is the open source Milvus, the new things in open source Milvus 3.0 that enables Zilliz to build the uh, vector lakebase solution on top of it. Okay, without further ado, I'm going to pass the time to Lee.
Sure. Can you guys see my screen right now?
Yeah,
Yes.
Okay. Okay. So yeah, let's start. So we start from introducing what is the 3.0, and the slogan is now semantic native, now lake ready. So yeah, we call it it's a very basic release of what we are working on. We call it lake base. And I'll introduce first why we need this kind of thing. So at the very beginning, we believe all the rack system will be not about the rack, but all the applications will start from serving, right? We start from solving one problem and build a layer upon the LLM and collect data, so serving users and solve some problem, and then they need to build their mode and about with their data they collect at the beginning. So to build the mode to from being copied by others and from eaten by the models, and then what we need to do is we'll accumulate data, send it to some kind of offline processing. So we need to do data discovering, we do fine learning, we do some batch processing and train the model. And then we have the newest data, newest stuff, and we turn it back to serving places. This is, we call it flywheel or a life cycle of the data inside now LLM agent applications. And the problem with in this sense, also call it continuous serving and a continuous discovery. But something break this flywheel what that. So if you need to have your data on serve for serving, you must be in a vector database like Milvus or previous Milvus and some kind of other data a vector database. And now you want to have a data inside your lake, inside your inside your say iceberg or whatever. So you need to work with this Spark or some kind of offline engine. You need to export the data to the lake. It takes 3 days. Say if I have 10 billion data, that is common, right? So it takes forever. And then you so for some kind of a new data, new coming data in the database, you need to re-export data, continuous doing this kind of thing. And also you need to do some analyze upon this lake. You don't have indexing upon it. You don't have any other structure upon it. So you have to put for search. It takes a lot of time. And then with some kind of after analyze, after processing, after some kind of pre-processing or post-processing, you need to backport this data back to the vector database for serving. And takes a long time also. It's not atomic. It has a conflict with data that's coming in. And this causes a problem that we cannot have this loop run very continuously. How we solve this problem? So we introduce something we call a lake base. Lake base. What is a lake base? So very intuitive. It's both. It is both lake and the base. So we build all the things from S3 bucket. It can be S3 bucket or some other lake like iceberg, lens, and delta lake, whatever. And 2 layers upon it. So 2 different track upon it. So you can do an online search, which is hot cache on the left of the screen. So in the yellow box, this is where the vector database serving. So we do online serving and do all the Milvus is doing right now. And in the other side, we have some kind of on-demand computation. We do discovery, iterator discovery. So you have a little search, you don't care about the QPS, you don't care about the latency, and you want to release resource after you search on it, and you do this. And also do batch processing, you do duplication, you do a lot of batch processing upon the Spark or Re, whatever. So you use this track, and they build all upon one copy of data. There's no data transfer between two systems, and this is what core Lakebase. And this Lakebase is now serving upon Zilliz Cloud. And for Milvus, we built Milvus 3.0 as a base, as a search engine upon this Lakebase. It's a build foundation for this Lakebase to come to be true. So right side is very simple architecture of this lake base. So every first layer will have a S3 bucket. Upon it, you will have a Lu, and Lu is a storage engine we offer. So for we'll talk about this in detail later. And we serve different kind of format of there. So hopefully we can we can be adapted to different kind of system, different search engine. And upon there, we build index upon this is one layer that make us very different from other things. We can make your lake operations offline operations pretty fast. And then we have one more layer, which is what I mentioned. So the Milvus, Zilliz Cloud to do on-demand, the Milvus to do the online searching, and have Spark, have a Ray over there to do the batch processing. So one copy of data, multiple engine. And with inside cloud, you have also Elastic Scheduler. You have a catalog service to monitor your data, your host without sort of easily, I'll say. So yeah, just one sentence to conclude. So Milvus 3.0 is still a vector database, and it's a serving and a base engine inside the vector Lakebase world.
So Li, we have added a lot of great stuff
Yeah,
in
yeah.
3.0 to enable the Lakebase solution. Can you like highlight some of the new things, new components that we have added in 3.0?
Yeah. So I'll follow. So this is the inner content what I'm gonna talk about. So I'll try to split this sharing the two parts. First is about lake related stuffs, and then it's about engine related stuffs. So about the lake, I'll say all listed here. So I'll introduce them one by one. The idea is one data, one index, no migration. So first, the most important thing is about the external connection. So what does it mean? So if you have a lake vector lake or data lake outside there, so already be there. It can be S3, can be lens, can be iceberg, whatever of them. So it's just a pile, parquet, whatever. So if you want to do some analysis upon it and you do some serving upon it, there's two ways. First is migrating the vector database. It takes a lot of time and very costly. And second idea is to directly search upon this data and use Spark, use whatever to directly search upon it. There's no index there. It takes forever to do so. So what we can do is we support something called external table. So you create an external collection over there, and the data still stay inside your original lake. And with this, we just create external resources. We just link the external resources upon this external collection, and we build a link over there, and nothing need to be done there. So no data migration, no copy over there, and we will automatically ingest the data and build the index upon it and store the index inside of Milvus and serving the indexing. It can be vector index, can be BM25, if FTS related stuff, can be JSON and some other scalar data. And also for the incremental data, so if any change happens in your lake, we will have a sync mechanism that auto detect what happened over there and just apply the very small granularity of incremental data automatically to our vector database. So you will keep having the latest data. And also you can piece to kind of load mode. You can do take, which means that you have all the data on the lake. And if you want to retrieval, it will also redirect you back to your lake. And then you can do lazy load, and you can do load, which means that, yeah, of course, serving, we can also load the data into the host in your serving to accelerate everything, accelerate especially the retrieval, right? So this is what we do for external collection. And feel free to interrupt me if any question about there. And so we have the external collection link the vector database Milvus with outside lake very tightly. And one more problem we need to solve is the storage. And so for external collection, we need to support different kind of format, right? So, and also you can store everything inside the Milvus and use some engine to access our Milvus data. Also, it also require our data to serve in a very open source format. So what happened previously is that we used Parquet, and then if you want to take retrieval one line, say 3 KB from this kind of Parquet, you need to load the whole row group up there. So about 64 megabytes and around 40K amplification over there. And we now introduce Vertex as our by default file format for everything, and it accelerated a lot. And also we built something called Loon, right? So it's kind of engine layer. We support not only about the Vertex, we also support Lens, Parquet, and some other file format over there, which means that you can easily adapt it to whatever your original format is, and also you can pick the most suitable one for your use cases, different scenarios. And also in the upcoming versions or some upgrade, we will have this. We will work on some push down to make the push down better to continuously mitigate the loading effort. And also we will doing Vertex upon the disk to save your disk space and accelerate the I/O between disk and memory as well. So this is about storage. And one more importance upon this lake-based idea, especially about external engine execution, is the snapshot. And we need to freeze the view of the data. So inside Milvus, it can be it is about the index and the data itself. So we freeze it, and it's very light operations. You don't need to do anything, but just record some metadata over there, and so all the discovery things and the long run batch processing can apply to the snapshot. And also this snapshot can be used to do backup and restore to accelerate the whole process. And yeah, this is about snapshot. And also, if you are working on some batching branching things, like you have a A/B test upon different kind of data, you can also use this snapshot to quickly achieve the branching effort. Yeah, so Spark connector as one of the most important part inside the lake. So we always need to, we of course need to connect with some execution engines. We pick the Spark as a start point, and Milvus can be read by Spark and be written by Spark, and in different kind of format as mentioned before. And whole Milvus can be embedded into this pipeline you build on your big data analysis system. And also we build some kind of internal AN or vector-based operators upon the Spark, and like oblong detection, like semantic deduplication, and clustering, something kind of like this. We can achieve this 10 billion data deduplication in hours level. We take full advantage of the AN effort, AN algorithm we have inside we built in a couple of 7 years. That's a long time, and we hopefully that this kind of operators can make all this batch processing very fast. And about also as a lake table, so something important is about schema's flexibility. In this version, we patched the final. We will finish the final patch of the schema flexibility to make it as flexible as possible. So we can add a column without anything. So it's a by default value or non-value, whatever. So we can fill it. It can be there's a two-way to fill this data we can talk about later, and then we can drop this column. About fill, we can do external fill that we can work with a Spark, and you can take a snapshot and use Spark to do outside add a column and just do a snapshot, and use Spark to do the external joining and find and organize the data to backfill to your table, and then you just then that's what happened. This is on flight. You don't need to stop writing, you don't need to stop reading, you don't need to stop anything. It's very easy. And then we can also do some inner backfill. So if you want to generate some new column from the existing column, like you want to survive the BM25, you want to survive some other, for example, you want to build a vector upon if you have a dense vector upon some kind of varchar or graph over there, so you can do this inner backfill, and it's very easy. It's also imply. Next one is about tax law. So as a lake, we want to serve in many different kind of data structures, especially for the blob, right? So for the unstructured data, and we want to start from the text. So text is first class and very easy to understand. The reason why we need it is because in the rack that we'll always have this BM25 text match over there. So the original data is it can be a can be an article, right? So or a paragraph, which is very long, so way longer than what we are doing. So the for the var chart is limited, and this is the reason why I want to introduce a text. So instead of just embedding into the collection, the table, like varchar, we have two different kind of ways to handle it. For a smaller one, we'll embed it into the table. For a longer one, we'll put it outside, but put it outside, and but all serving upon the storage FFI, the interface. So which means that it's a combination, and it's also built a fundamental for the general blob. So in the future, so maybe next version will support some other binary, this kind of blob can be video, audio, this kind of thing. And also in the picture you say we also have the structure over there. Now I'll introduce the structure later, but maybe we should put there. So this is about the late creative stuff, and I just want to give a pause over there. So if any question, if no, I can continue and we can take it later.
Yeah. So there's a question from the chat room. You're always curious about the Lakebase use case. Is that primarily for offline analytics? How does it relate to production applications serving data from Milvus in their workflow that more Lakebase can be used as part of evaluation and delivery of production index? Li, would you like to address this question by kind of going back a few slides, or we can leave it to the later one if you have a specific slide for that?
Okay, give me 1 sec. The question is about how should we use the Lakebase, right? So correct me
Yeah, it's
now.
about the Lakebase use case and the relationship between the online and offline workload.
Yeah, so I'll give some examples. So we have a lot of scenarios we have different scenarios upon the vector search, right? Sometimes you can do online serving, which is the most easy one. So you have your customers keep coming in, you have a high QPS and low density requirement over there. So comparatively, okay. And then it can also be some other scenarios, like you want to do some discovery, which means you have a lot of data analysis. They are trying to figure out, for example, you are doing some feature engineering. You want to try to find some. You have a scenarios that want to do a data mining, and you want to You want to mine more data similar to this. You want to say keep polishing your query until you find some kind of scenarios. And in this case, is the search is pretty. You don't need a high latency, right? So you need a low latency because the user is analyzer. It can take seconds or even minutes level of latency, but you don't need high QPS. In this case, you can do this iterator discovery. We call it on-demand compute, and you don't need to pay for anything but the search. You search on it, and we'll pull up the resources and partially load it over there, and you can finish the search and we release the resources. We call it discovery scenarios. And also you can do some batch processing, saying that you want to train your model and you want to have a deduplication, say always do pre-train, right? So you need to do all the all the data, say it's 10 billion level, you want to use Spark to do so, and you want to do upload detection, you want to do some this kind of things. Also, in some cases, we also have customers to they have already polished their query. They find out they mine the scenarios they want, but they will need to have a post processing upon the Spark. Say I will say a search, say 1 million top K, and this 1 million data I will use Spark to do the post processing to fill out some other according to other stuffs and some user defined functions, and then we'll finally get the final answer we want. This is a couple scenarios we want to apply in the lake. So the connection is, this different scenarios. So we want to do it upon one storage, one data. We don't want to transfer data, copy data over from system to system. So this is why we build this, we call it Lakebase. We do one copy of data serving everywhere.
So I can also give a real world example. So from the application developer's perspective, you might be developing a corpus for serving in production. Right? So for that corpus, what's behind that is a suite of pipelines that can continuously evaluate and improve this corpus of data, which will use, for example, vector search as a building block. And you might be, curating a data set to retrain the model so that you can generate a newer version of the corpus for serving. And as part of that workload, what you can use is whether it's Milvus or Zilliz Lakebase to support this offline and data curation, model training use cases. And the baseline data used for, say, training data curation, that could be different data set than what's being served. What's being served can be a smaller, more distilled and fresh, the most fresh version of the that comes from this training process. But what's supporting the training could be a much larger data set. And this one problem that Milvus 3.0 and Zilliz Lakebase are trying to solve is that how do we support vector search workload kind of ad hocly or periodic batch workloads in very cost efficient manner. And that's what the all these new functionalities such as storage engine and on-demand search from Zilliz are trying to solve here. Hopefully that answers your question. You feel free to ask follow-up questions.
Yeah, so we can continue, and then we can, if still some confusion, we can help on that later. And for the next one is about execution, about as a semantic native execution, we definitely need to build more capability upon it. And so first is order by. Now Milvus from 3.0 support native order by scenarios. You don't need to retrieve the huge number of data, right? So you order by on the client side, first save the bandwidth, and second one in the first, for example, in the query side, you can push all the order by to very low level into, so you will have very accurate result. And the search side, so you can also, so inside Milvus, we have 3 layers. So we have a multiple segment. We will do the reduce upon the query node, and the multiple query node will do reduce upon the shard, and then reduce upon the proxy, so we have a lot of level. So for search order by, we can also push this order by to the lowest level, which means that you can have a higher recourse upon your request over there. So this is the reason why we do order by in server side. And for aggregation, so goodbye, we now support goodbye for the aggregation for queries. So it's pretty easy, just like what Seco did. And also we support the search goodbye or search aggregation. We also people call it facet. Maybe people are more familiar with this name. So we will say top K about what, and we will aggregation the size, the number, the maximum, mean upon the result we found from the result we search. And yeah, so this is about aggregation. And the structure list, what I mentioned previously. So why we need the structure list? The reason why is sometimes we need to multiple vector to represent one object or one entity. So like you have a multiple of paragraph to compose the article, right? So you also maybe some paragraph is made of so many different kind of words, tokens, and some picture is made of some smaller picture, or some kind of video is made of slides, this kind of thing. But you want to search or you want to store it in one entity. So it can serve in this kind of entity level search. And second one is some later interactive algorithm we can support this natively, which is Copilot people mentioned before. And the third one is no metadata redundancy. So this is another important reason we introduced this. So you don't need to saying that you have a picture, you have a video, and tons of slides for this video, and you don't want to duplicate the metadata for all the slides, right, as a row, but you want to store them all at the row, so you can save the space for the metadata. And so we now support, actually the structure is structure list, this structure data structure was introduced in 2.6, but it's a little bit improvement over 3.0 is first we support element level search and filtering. So previously we only support entity level. Now we support element level. So you can use element as a represent entity. You can use the element just as element, and also you can filter upon it. So it's more flexible and yeah, so more easy to use. And second one is from the algorithm perspective, we support more flexibility upon this entity level search instead of just using maxing, right? So the Colbert we mentioned before. So we have three different kind of ways. First is token AN. We support this previously, which means that we just use all the embedding, each embedding as individual one to do the similar search, and then we do a refine. And Milvus is another one. They just simply condense, we just compress all the vector inside the vector list in the structure list, so together to become one vector. So this is how it does. And also Lemur is learned based. It built upon MLP to compress all this vector into one. And yeah, the second and third one is trying to minimize the size of the index, try to have only one vector for one entity, and but has the information about all the small vectors. And on the right side, there's a performance. There's a recall difference, and upon different two different models. So we have 4 data sets and 3 solutions. Most left one is about the token AN, which is the original one. The second one is about Milvus, and third one is a Lemur. So you can see most of the cases, Lemur can match the recall as a token AN, and sometimes even better. And also do a bunch of testing. We have different ways to indication to take for this kind of high discrimination one, and short documents use token AN, and with some long documents use the Milvus. And for the low discrimination models, we use the Lemur, since the learn-based can learn some detailed things from it instead of just mathematically add together and to do some average upon it. And also some visual docs, we'd better use Lemur and Milvus. And the high this is a high length variance one, we just avoid use the Lemur because it can break something. All right, this is about our new algorithm introduced for the structure list. And we also have a big improvement upon the sparse indexing. And personally, we just do simply inverted index for sparse. And in this version, we introduced compression and quantization for it. So first is compression, and we can compress the data in very very small size, but it will not affect the performance a lot. But sometimes it can also accelerate the performance because bandwidth usage of the memory will be lower. Yeah. And also the quantization, we can quant FP16 and U16 for the sparse vector, and also some pruning, some kind of thing. So on the right side is the performance and size of different kind of version we are using. So the red one is Milvus 3.0, and blue one is 2.6, and black one is Elasticsearch. And you can see we have some performance. This is a top 10, right? So I have some performance improvement upon the 3.0 and a big size improvement upon there because we have the compression. And also we introduced Cindy to the sparse vector. So on the right, the graph is the mechanism of Cindy. Cindy is pretty easy. We just cut them into windows, and for each block, each posting list, we just put into pieces, and we can each window can perfectly fit the SIMD size. So actually, it's just a brute force search upon the inverted index with SIMD, and so it very perfectly fit for the PM25 scenarios, which is not learned sparse. So the reason why is because the PM25 is more sparse, it's sparser. Okay, for the learned sparse, it's somehow denser, but also sparse vector. And we can see that from the learned sparse, performance is 10 times more than 10 times better than what we did. This is comparing with 2.6 scenario, just the inverted index, inversion index. And for the BM25, it's a little bit better, but in some cases worse. So for the learned-based ones, we can use the Cindy. Okay, this is some very important. Well, I will finish some very important features introduction, and then I want to steal some others also important, but just I don't want to mention too much. So I'll give a quick review. First about the phase family. So for open source, instead of supporting say one by one the index one, okay, we also support what we supported before, like the IVF, the HNW, scan, whatever. And now we introduce a whole phase family. Now you can say, hey, your vector is your index is a phase, and you can config anything that you config to phase to apply it into Milvus. So it's a vanilla phase support, and SVS, panorama, PQ, all these new stuffs and can be introduced with this way. And second one is min hash dating data out. So at the last version, we we support dating data out, and we support this kind of deduplication scenarios, but we didn't build in the min hash inside the Milvus server side. So we need customer to use min hash to transfer their tags into binary vector, and then use jcard here to do a deduplication. And nowadays we support building min hash functions, so you can directly have your text in and do deduplication, directly inside the Milvus. And third one is the non-verbal vector support. Now you can have a non-vector columns, and this make us be able to add a column with add a vector column because it's nullable, right? So previously it's not nullable, so we can never add a new vector column. Now we can do it, and also some kind of row, so you don't have vector over there, just leave it empty. So previously we need to fill it with some 0 or -1, whatever, so it breaks indexing and also makes the storage very high. So nullable vector support from 3.0. And some other ops and governance improvements. First, we support a customer dictionary for BM25 for the word splitting. And so, second is we support entity level of TTL in some kind of ways you want to have the data be recycled themselves in entity granularity. You can use this one. And third is force merge, and it's just similar to Elasticsearch force merge. And if you want to do some kind of ultimate optimization upon your performance, especially in your graph, if you're in a graph indexing, you can call force merge. You'll try to evaluate how big your segment can be, and then automatically optimize your segment into that big, so it can perform. You can provide better performance upon it. And also, Woodpecker service as an individual service will be ready to use from 3.0, and we also will provide some kind of script and to ensure that we can migrate from Pulsar or Kafka or whatever MQ to Woodpecker. Yeah. So this is all we have for 3.0, and for some more in the future, yeah, I can try to introduce a little bit about this. We want to have the pushdown, prediction pushdown, as mentioned before, which will make our external table scenarios way faster. And also we'll have a primary key deduplication. So then we will difference the collection between the primary key collection and non-primary key collection. And also, we'll have a shard split for some shard that is have a lot of data. We want to split automatically. For now, we need to pre-assign some of the numbers, suitable number for the size, right? So it's somehow painful. And then we'll support UDF. So in different kind of ways inside Milvus, it can be ingestion, can be post searching, can be pre-searching, whatever. So we have a lot of points there. So you can write the UDF and apply in the search process, in the whole Milvus process. And the UDF can be hosted by a array cluster. And in the Spark, we have more batch process and operators, and also performance optimizations. And the table format will support more table format like Delta Lake and some other PyMO, maybe in some other lake, and also the capability of expansion. And this is about the lake, and the table format will support different kind of evaluation, schema evaluation, and time travel, and rollback over there. So that is pretty much what we have today, and thanks for listening.
Yeah, thanks, Li. That was a lot of great new features from Milvus 3.0. I believe that the audience will have a lot of questions. And the second part of today's webinar is AMA. Just ask us anything. Yeah. So anyone from the audience, please feel free to grab your mic and speak about the questions, or feel free to just type the questions in the group chat. We also have a few questions that we collected from the audience, but I would like to go over the live questions first. So another question from you is, could you point me to more information about sparse embedding features, split?
Yeah.
I guess the question is regarding any optimizations that we did for split, like long like high dimension sparse vectors compared to the M5.
Yeah, actually, split itself is kind of learned sparse, right? So we try to divide the sparse into different ones, which is first is the BM25, so you can directly use tags to say, hey, I want to do BM25 over there, and the other one is learn sparse, which you have models of it outside, and learn the sparse vector and use a sparse vector directly inside Milvus. And in these cases, we provide SND, which can because learn the sparse is somehow denser compared to with BM25 scenarios. And SND this way, although it is need more calculation, but very high efficient, since you can take full advantage of the SND and performs way better. So you deserve to take a try. So any more information you want to get from there?
Yeah, we can go through the pre-registered questions. Feel free to ask any more questions while we'll go through this. The first one is regarding stateful architecture, which calls sovereign self-hosting. Where do you see gaps in performance and standard enterprise models? I guess the standard enterprise models refers to our Zilliz cloud, right? So this is kind of a there has been a lot of questions regarding this part. Right? what's the difference between self-hosting and using a vendor, fully managed service like Cloud? They, all have their pros and cons. Lee, what's your perspective?
Yeah, so if back to 2 to 3 years, I'll say the bigger difference is about the engine itself. So we built a brand new engine over there, so the engine can be way faster, say 10 times, 5 to 10 times faster than the outside public engine. So all the features are the same, but the performance is a bit different because of the engine. And but back to today, I'll say it's a lot of difference about the ecosystem, especially. So we have a building pool for indexing, which means that your data can be indexed by a shared indexing resource with the global users, which is a very fast pool, and your indexing can be very fast, and you need to spend any pennies for any coins for your indexing, and you have on cloud you have you have auto scaling, you have this kind of lake-based scenarios we mentioned before. So we'll have one data and different kind of operation upon it. You will enjoy all these features, and you have some monitoring, you have some alerting, some kind of resource management, and a bunch of them for now. Yeah.
Yeah. From my perspective, serving both this cloud customers and working with the community users of Milvus, I think it comes with a few angles. If you are, for example, DevOps engineer or SRE helping maintaining the Milvus cluster for an enterprise, the difference is now you got peace of mind, right? You don't need to deal with every single piece of dependency. You don't need to rebuild the wheels that we have done on this cloud fully managed service, such as the auto scaling feature and also shared tool for some compute heavy and bursty workloads, such as indexing. Um, but in addition, you also got SLA guarantee for reliability. 3.5 SLA, that's what we provide with enterprise plan on this cloud. If you are application developer, it's more of the ease of mind. Now you don't need to worry about the infrastructure at all. There's a vendor helping you managing this. And the functionality on this cloud, it intentionally abstracts away some of the nitty-gritties of the open source implementation, such as for index, whichever index algorithm that you are using, HNSW or some other popular ones, you need to tune the parameters to achieve the performance that you desire. However, on this cloud, you can enjoy the benefit of what we call auto index, which use all the statistics and machine learning based approach to find the best tuning parameters on the proprietary index type that this cloud provides. So it works for a diverse workloads and diverse data sets. So you don't need to find the best EF construction and AM, which are parameters in HNSW anymore. So it's much easier to develop application on top of that. You just need to think about your data model. And once your data model is done, you ingest the data, you don't need to care about the performance. The performance just comes great out of box. Of course, right? So for this cloud, the fully managed service, we only provide it on public cloud like AWS, Azure, GCP. So if you are running in air gap system or you have on-prem hardware, then unfortunately, this cloud is not available there. So self-hosted Milvus open source will be a great option for that case because you have all the control and you can deploy it anywhere on Kubernetes or Docker.
Thanks.
Yeah.
Yeah. So
Let's
should,
move
should
to
we
the
take
next
the
question.
next
I
one?
think this question about Minio, that's better for you to answer.
Yeah. So what is that?
So what do you recommend for users still using Minio? We all
Oh,
know that Minio has changed
okay.
their license, right?
Yeah,
So
yeah,
the
yeah.
recommendation is stay as is, migrate, or there be a migration guide for 3.0.
Yeah, so for production deployment, we always suggest or encourage users to use OSS like third bucket, right? So or GCP or provided by GCP or some other cloud providers. And Meow, we will continue supporting it. Definitely for now, we will not deprecate for now. And so we don't need to concern about it, but also the migration between the Meow and S3 is workable, or no matter do it through the Meow's migration or do a Meow's migration to backup and
Mhm.
restore. And yeah, that is what we can we can offer right now. Yeah.
Yeah, I guess the high level suggestion is the high level background to highlight here is that even open source Milvus, it supports integration with all the popular object storage services, such as S3, or for GCP, I think it's GCS and Azure Blob. Um, Minio is one option among those. Particularly if you prefer to self-host your object storage service, then you can use Minio or the ones that Milvus may support in the future. Um, so even kind of stepping out of this context a little bit, right? Even without this this license change, our recommendation is to use fully managed object storage for production service because you can enjoy the ease of mind of not thinking about this.
Yeah,
If
yeah,
you
and
already have Medium, I think it's fine to stay on Medium for the foreseeable future.
yes, yes. For now, we didn't see a big problem from me and also maybe it's safe for now to keep using it if you need it. But so for this open source one, and always people get some kind of things in trouble, and yeah.
And the question is pretty big, right? What changes, improvements, and testing in this version? Well, I would like to rephrase it as what's the change or improvement, the lead that you are most excited about in 3.0?
Okay, so it must be the lake base, right? There's a reason why we introduced 3.0 as a very as a major version. So we want to say that instead of vector database, we want to enter so whole company that want to get into a new chapters, which is about our target is pretty clear. So our target is for scale, bigger scale, huge scale, and upon cheaper and cost. So this is our target. So this from this 3.0, we start to we will have a very steady step upon this road, and about the external table, about flexible schema and snapshot. Everything is built for the one target is one copy of data and serving everywhere. So this whole batch is what I think is the biggest change for this version.
Cool. And the question also mentioned about testing, which is something that a lot of open source users, didn't pay much attention to. I'm curious, can you share some interesting story from our QA process in the 3.0, right? So was there any kind of interesting bug being discovered and fixed, or was there any particularly challenging thing to discover or fix?
Yeah, but bugs is pretty hard to say, right? So a lot of bugs, it can be very uh ridiculous, can be very reasonable, whatever. So we have some bugs that can we searching for a couple of months, right? So it's just because of a compiler problem. But yeah, this is a very pretty common. But something very interesting. The test I want to say is since we are getting to the huge size and testing, so the overhead of testing is way higher than the expectation since we are or the amount of data we want to do want serving right now is way bigger than what we expected before. So previously we just doing 1 billion serving, 1 to 10 billion serving online. So that is pretty much what we want. But for now, so we are targeting to hundreds or even 1 trillion. So that is another different kind of thing. So we spend a bunch of time on building scenarios, on testing, on some kind of infrastructure tuning to adapt this big number of data to make it to make it more suitable for more ready for customers. Yeah, this is pretty much what we. This is the reason why we take a long time before the release. Actually, we have already released pre-version, the beta versions a couple of months before. So all this kind of times after that is working on the big size evaluation and preparation. Yeah.
Cool. Next question I can take. Any plans for GraphDB support? A knowledge graph would be a good add-on. Well, the short answer is that we're not trying to be a GraphDB, right? Never. That being said, I understand that there's a lot of use cases of graph, right? Like using knowledge engineering to distill the information in a structured way from unstructured data. Well, we actually built an interesting product called Vector Graph Rag as a reference implementation. How could you model the knowledge entities and their relationship, like one hop or two hop neighbors, in a Milvus native data model? So I'm going to share this in the group chat. Feel free to refer to this, and you can just use it. It can just works out of the box. We want to provide this as a reference implementation for people who are trying to build knowledge graph or graph rag on top of Milvus. For most of the cases, I think it works pretty fine. It don't really need a GraphDB to store the knowledge entities, because most of the time for graph rag, what you need is just one hop or two hop relationship between the entities. You don't really need kind of graph traversal per se. So that just storing, the idea is to store the adjacent neighbors of any node in Milvus as an array field of IDs of those entities, which are other rows in Milvus collection.
And
Okay.
just one more words upon it. So the problem is that definitely you need to have a model handling the relationship between entities previously, right? To pre-processing, spend a lot of tokens upon it and a lot of effort upon it. But nowadays, you definitely can do query rewrite upon a dense search and to achieve the similar result with much lower effort. This is a trend to what everyone is doing.
Yep, just like you said, think of the box, graph
Yes.
rag. Just admittedly, I feel we hear a bit less than, like, for
Yeah.
example,
Yeah.
2 years
Yes.
ago.
Yes.
Yeah, just think of other alternatives. But if you want to have a structured representation of the entities or concepts in your corpus, well, feel free to use knowledge engineer. Okay, next question is about full text search performance. Has the performance improved? And what are the difference between Milvus 2.5 and 3.0 in full text search? I think specifically about performance and functionality. I think that you can think about.
Yeah, I think we already introduced most of them, right? So we have the biggest. We have three things, biggest changes over there. First is we do the compression upon the inverted index. So we do the posting list compaction, and then we do quantization, and then the third one is Cindy. So first two can offer us a very low size of the indexing and offer some slightly better performance, I would say. So it depends on your scenario. So if you are bottlenecked by the bandwidth of the memory, yes, of course, you can save a lot of them. So you can save the world. And if you just bottlenecked by the execution, so I don't think it will be too much difference. So pretty different on what happened in your cases.
Well, I would say cost saving is as important as performance improvement. So the main goal
Yes.
of this compression is cost saving. So
Yes.
yeah.
Yes, as mentioned. So you with lower per resource, you can double the host, right? So to improve the performance. Anyway, so about the Cindy. So as mentioned, we answer yours question. So very simple for the learn spots, and you can accelerate it a lot of times compared with pure inverted index ideas, and feel free to take a try. Yeah.
Cool. The last question is, any update on the Java API, or do we have any future plans for a Java API?
Yeah, we have a Java API, so we will update it to the latest version very soon. Yeah. So along with release or just a couple of little bit delay after the release of 3.0. So we catch up.
Yeah. So Java SDK is natively supported by us.
Yeah,
Because we maintain multiple SDKs across different languages, for example, Python, Node.js,
Python,
Java,
Go, yeah,
etc.
Node.js,
Yeah.
Go. Yeah, Go
Um,
and C++ and Rust we support right now. So that's still under improvement.
so they do have slightly different pace. So for example, for new functionalities, it's first supported by definitely Python and sometimes Go and Node.js, and then will be replicated into other SDKs, for example, Java SDK. And if you have any kind of particular functionality that you see as a gap, feel free to let us know, raise a ticket on, raise an issue on GitHub, or just ping us. Okay, that's all the questions. I don't see any more questions from the audience, so I think that's it. Thanks a lot, Lee. Jenny, back
Yeah,
to you.
thank you.
Yeah, thank you. That was a very well-rounded introduction of Milvus 3.0, and I hope everybody has their questions answered. And if not, or you need to revisit some of the topics we mentioned, we'll be sure to send out the recordings and you can revisit. And here are some of the resources you might find helpful. Here is the QR code for GitHub. You can follow us on GitHub. And then on LinkedIn, we will post some of the events that we're hosting and some of the technical blogs too. So stay tuned with us on LinkedIn. If you're interested in trying the enterprise product, which is Zilliz, we do offer a free like on your sign up, you will get a $100 credit. You can also follow us on LinkedIn and contact us through these links. And thank you, everybody, for joining us. And at the end of this webinar, we will be having a short survey, which is only 7 questions. So it will take you maybe fewer than a minute to finish it. So if you're, please just leave some of your responses in a survey to help us maybe pick better topics next time and help you answer your questions better, make your experience better with us too. And thank you again, everybody, for joining our webinar and stay tuned for the next ones.
Thanks. See you next time.
Thank
Thank
you.
Bye.
you.
See you.
See you. Bye.